Okay, so now we're going to look at horizontally launched projectiles and how to solve problems that you may encounter that deal with just horizontally launched projectiles. So here's an example. A soccer ball is kicked horizontally off a 22-meter high hill and lands a distance of 35 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. So the first thing I want to do is I want to make X and Y components here, okay? So I have all my vertical, or all my horizontal information here, and all my vertical information here. And I'm going to draw a little picture. And I'm just kicking the ball straight that way. And the cliff is 22 meters high. And the distance it's going to land is 35 meters away. Okay, so 22 meters high. So this height is going to be my y. So my initial y is going to be 22. Since the ground's where it lands, my final y is going to be 0. And the x, my initial x is 0, but my final x is 35. Now, some things that I know. I know that in the x, my acceleration is always 0. We talked about this in the last video. And in the y, my acceleration on Earth is going to be negative 9.8. Time is a weird one because time's going to be the same for both in the x and the y, and that's the only thing you're going to see is be the same. Sometimes velocities may be, but not always. So now, because we're kicking horizontally, my initial velocity in the y is 0. Okay? So, always when you face a problem like this and you have this kind of information, you got to think about your kinematic equations. And the first one I go to is I want to find time. If I find time, it's good for both sides, and then I can start to find whatever it is I'm looking for, in this case, the initial velocity in the x. So to do that, I use the equation where I go from before, where xf, xi, plus vit, plus 1/2 a t squared, okay? But I'm going to do it in the y, so I'm just going to substitute y in for my x's, okay? And this is going to be initial velocity in the y and my acceleration in the y. So my finished spot in the y is 0. My initial spot is 22. I add to that my initial y velocity, which is 0, multiplied by t, plus 1/2 times my acceleration in the y, negative 9.8, times t squared. And I see 0 times t is 0, and I get 22, so my equation is going to be 22 plus, if I take 1/2 divided by negative 9.8, I get negative 4.9 t squared. So it's 22 minus 4.9 t squared. Subtract 22 from each side, and I get this. Divide both sides by negative 4.9. And then I take the square root because my t is squared. And when I do all this math, I get my time to be 1.5 seconds. That tells me that in the y, it's 1.5 seconds to hit the ground. I also know it's going to take 1.5 seconds for it to travel all the way to 35, right? So I know time, I know final and initial position, and I know initial velocity. I don't know final velocity, right? It's the same as my initial because my acceleration in the x is 0. So I'm going to use the same equation, but now I'm going to solve it with my x information. And I'm going to say x final is equal to x initial plus vit in the x, right? Plus 1/2 acceleration in the x times my time squared. Now, when I go back and look at what I have so far, final position 35, initial position 0, right? So final position 35, initial position 0. I don't know that because that's what I'm solving for, but I know my time is 1.5 seconds. And I go plus 1/2 ax. As you'll recall, no acceleration in the x, so that's going to be 0 times 1.5 squared. This is all 0, because when you multiply by 0, you get that. So essentially, my equation is distance is equal to velocity times time. And I just divide by 1.5. And my x velocity, or the velocity that I'm kicking this ball at, is 35 divided by 1.5. And that comes out to be, lost my notes there, 23.3 meters per second. And that's the horizontal velocity that I launch at. So that answers the initial horizontal velocity of the soccer ball. I'll do another example. I got a cue ball leaving a 0.6 meter high table with initial horizontal velocity of 2.4 meters per second. I want to predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing position. So again, I have a ledge, okay, and it's 0.6 meters high. That's 0, and that's my distance in the horizontal. I'm going to try to find this, right? I'm going to be looking for this. I also know that I'm propelling this object off the ledge at 2.4 meters per second horizontally. Okay, so I also want to find time. So I'm going to find this and time. Okay, and now I just look at what I know. Remember, I got to break it up into x and y. So in the x, initial position is 0. My final position, that's what I'm solving for. Initial x velocity is 2.4. Since my acceleration is 0, my final velocity in x is also 2.4, and I don't know time. So these are the two things I'm going to be solving for in the long run. Now I know I'm 0.6 meters high. I start off at 0.6 meters, and I finish on the ground. So it's 0.6 initial position, 0 final position. Y velocity, since I'm launching horizontally, right? My y velocity is 0. And in the y, acceleration, and we're going to assume on Earth, is 9.8 meters per second squared. Okay? So I have acceleration, and this is going to look very similar to the last problem. First thing I want to do is say, okay, so if I go y final is equal to y initial plus initial velocity in the y times t plus 1/2 acceleration y times t squared, I can solve, right? My y final is 0. My y initial is 60. My initial y velocity is 0. I don't know time. Plus 1/2 negative 9.8 t squared. And my equation is going to be 0 is equal to 60. That's going to be nothing. Minus 4.9 t squared. And so I solve all this and solve it like you did before. Bring the 60 over, divide by negative 4.9, take the square root. My t for this problem is 0.35 seconds. And you can definitely check my work. So I got the time. So this is 0.35, 0.35. And now I want to find that final position. And I go to xf is equal to xi plus initial velocity in the x times t plus 1/2 a t squared. Now, if you recall from the previous problem, acceleration is 0, right? I mean, we look at everything. So x final is what we're solving for. Initially, I start at 0. My initial velocity in the x, 2.4. I was able to find the time, which is 0.35. And then I add that to 1/2 times my acceleration. And as I just said, the acceleration in the x is 0. And I multiply it by t squared, which is 0.35 all squared. 0 times all that is 0. That's 0. xf is essentially 2.4 times 0.35. and then I punch those numbers into my calculator, and I get 0.84 meters. And that tells me in the end how far it traveled in the horizontal to get that answer. So to solve these problems, big thing, x and y, make sure you have separate variables for each. Fill in everything you know, keeping them separate. Know time's the same in both. And know in the x, your acceleration is 0. And in the y, it's negative 9.8. And then you just use equations to solve. Work on these problems. If you have questions, please ask.